Okay, college algebra, we are going to go over some factoring today. I think most of us are pretty comfortable with our basic form of factoring, so we're going to do our special patterns. If you've got any questions on the basic stuff, we'll cover those in class before we get started on our practice problems. So, to dive right in here, we're going to talk about factoring cubes. You might need a little refresher on that. We have a sum of two cubes and a difference of two cubes. By cubes, we mean we're taking something to the third power. Now, what you need to understand here is in a sum of two cubes, here is our pattern. We are going to start out with a binomial, which is simply, whoops, I forgot to add a layer here, sorry. You're going to start out with, let's go blue here, whatever that first term is, whatever you are cubing, plus whatever you are cubing here in the second term. The last part of your pattern then goes into whatever you cubed here, you square it. Then you will subtract your middle term. Your middle term will be whatever you're cubing here times whatever you're cubing here. So here we would have an A, B. And then you go on to add whatever you cubed here and square it. Okay, so it's a fairly easy pattern to remember. It's what you cubed here plus what you cubed here. Then you square that term, you subtract the product of those two terms, and then you add the square of your second term here. So, an example here, we've got 8a cubed plus 1 here. Okay, so actually, first off, we should have this should be in parentheses, I'm sorry. Go there. 8a cubed plus 1. I'm sorry. I messed up again. It should not be cubed here. So, or be in parentheses, I'm sorry. So, right here, it looks like we've only cubed our a, right? So, what we need to look at is what did we cube to get 8? Well, we cubed 2. So what are we cubing? What did we actually cube here? We cubed a 2a. I forgot that I had already written this out this way. So what did I cube here? Well, I cubed a 1 to get a 1. Alright, so now I've got the sum of two cubes. Well, I write down what I cubed there, plus what I cubed here. Then I square this, which would make it 4a squared. I multiply these two together and subtract them, so minus 2a. And then I square this. Okay? So that's your pattern for the sum of two cubes. The difference of two cubes, the only thing different is right here, it's going to be subtraction, and both of these terms are going to be addition. Okay? So, with that being said, you would have a minus a b, then you would have an a squared plus ab plus b squared. So, same pattern, all we did was change a couple of the signs around. Okay, so let's go down here and figure out what we have here. What did I cube here to get 27x cubed? Well, I cubed a 3x. What did I cube here to get a negative 1,000 or a 1,000? I cubed a 10 to get 1,000. So the pattern goes with a subtraction, so I'm going to have what I cubed there minus what I cubed there. Then I'm going to square this, meaning I would have 9x squared plus, if I multiplied both of those together, 3x times 10, 30x, and then when I square that, I would have plus 100. Now the thing is here is not to really handle this negative in your calculations of these values. You've already accounted for the negative. That's what accounts for these signs, for this one being negative, these two being positive right here. So once you have plugged in those signs, all you're dealing with is a 3x and a 10 to get all those values. Alright. Now note the middle term, one thing to remember, the middle term of the trinomial is the opposite of the sign that it is contained in the original, or in the binomial. Okay? So you'll see up here, this one always matches what was here. Okay, the negative, the positive, the positive. Then that middle sign is always opposite of that. Down here it's positive, up here it's negative. Alright. So one more example, 729x to the 6th power. Well, what cubed is 729? You could do some, put that in your calculator, you would realize that is 9. What do you have to cube to get x to the 6th power? Well, you'd have to cube x squared, because if you remember your power to a power rule, 2 times 3 would be 6. When you have a power to a power, you multiply the exponents. What did I cube to get 125? Well, I cubed 5. The negative stays there. Then that would make this first sign positive, and this second sign over here is always positive. So I'd have 9x squared. I'd have a 5. Now I've got to square this. So when I square the 9, I'd have 81. When I square an x squared, I'd have x to the 4th power. Now when I multiply those two together, I'd end up with plus 45x squared, and I square this, plus 25. Alright, and that is factoring cubes, short and sweet here. Now to factor completely, because when we say we want to factor, we mean we are going to factor completely. And that means factoring each term until it is, in fact, prime. The first thing you're going to do every single time is, if there is one, you are going to factor out the greatest common factor. Whoops. Factor. If there is one. I should probably erase that. That's not very nice looking. Factor. Okay. For example, if I look at this, this may very well be the difference of cubes, but I know that that 6 is not a cube. I can't cube anything to get 6. So what I need to look at this is, can I take anything out? Well, yes, in fact I can. There's a common factor in here. Each of those are divisible by 6. So that if I factored out that 6, I'd have x cubed minus 8y cubed, and then I notice what I'm left with is a difference of 2 cubes like I had up here. So if I were going to solve that completely factor it, I would, well, what did I cube here? I cubed an x, and it's the difference, so that remains the same. What did I cube here? A 2y. Now I would square that term, and that's going to be positive. I'd multiply those two together, so I'd have a 2xy. And then I would square this, I'd have a 4y squared. Alright, so that shows you how factoring out the greatest common factor can make your make factoring a binomial or a trinomial a lot easier. After you factor out that greatest common factor, you are going to look for patterns. And those are always based on the number of terms. So we might be looking for the difference of two squares. We might be looking for a perfect square trinomial. If you have questions over those, I can answer those in class. But I'm not going to go over those in depth here, as you've had those in Algebra 1 and Algebra 2 at this point. So, all right. So two-term patterns, real quick. This difference of two squares. Just do a real basic one here. If I have an a squared minus a b squared, when we say difference, remember it's subtracting. And this is a square and this is a square, so it's the difference of two squares. Remember, that pattern is just the first, whatever I squared first, whatever I squared last. One of these binomials will be positive, one of them will be negative. You'll subtract. And that's why you end up, when you multiply these out, you end up with only two terms, because that middle term goes away, because you end up with a negative AB and a positive AB. They turn into a 0. The sum and difference of two cubes, that would be the other pattern you're looking for, and we covered those up top here. So see number 1 on factoring cubes. Alright. Okay, so we've got some three-term patterns. You know, your basic factoring that you guys were used to being exposed to originally. This perfect square trinomial, the pattern here, if I've got something squared plus 2 times what I squared times there times what I squared there. Remember, these patterns go like this. And of course I forgot that layer too. Boom. There we go. Remember, it ends up looking like this if you multiply the same binomial times the same binomial, which in effect is this binomial squared. The one thing you have to absolutely be sure you recognize is this is not a squared plus b squared. Remember, you have to take this binomial times this binomial again, right? Like we have right here. And when you have a binomial times a binomial, it's distribution. You have to take this a times each of those, this b times each of those. You may have been taught the acronym FOIL for first, outside, inside, last. Remember, it's just distribution. It's FOIL if it's a binomial times a binomial, but it is simply just distributing everything in this one times everything in this one. Okay, when we have a perfect square trinomial where we are subtracting in each, what that does is that changes the sign of the middle term. So that's a minus b squared there. If it does not fall into one of those patterns, we simply use trial and error. Okay, we figure out, you know, what two numbers when multiplied together will equal the last term, but when added will equal the middle coefficient. Okay, so now let's say we have 4 or more terms. There's patterns there as well. 4 or more terms. First off, you could group in pairs. Okay, what I would notice right here is these first 2 terms contain an a, which I would be able to factor out. So I'd factor out an a and I'd have b minus c. These 2 right here contain a d, and I would actually factor out a negative d. If I factored out a negative d, then that b would be positive, and then that c would then be negative, right? Because I'm dividing out a negative d. Now what I notice is I've got the same thing in parentheses here. I'm taking an a times this, and I'm taking a negative d times this, and we can set that up as a binomial, so a minus d, because I have to take a times this b minus c, and I have to take negative d times this b minus c. Well, if I set it up like this, remember this is simply distribution. Remember, we could say FOIL, but it's just distribution. I'm going to take this a times this, and this negative d times this. That's the same thing I'm doing right up here on this line right here. Okay. So that's one that oftentimes gets overlooked. But that can help us when we've got 4 or more terms. We can group those together. Grouping with a pattern, we can look for the difference of two squares or a perfect square trinomial. In part A here, the difference of two squares. Let's say I have this one. Here's what you need to look for. Yeah, I can look at this as having 3 different terms, or I could multiply this out. But what I would prefer to do is think about this as a difference of two squares. I'm taking this, let's think of this just as one thing, and I'm squaring it, right? And I'm subtracting this squared. So that is the difference, right here, of two squares. This being the first, this being the second. So what I can do is kind of set this up. As two binomials, because I can factor the difference of two squares into two binomials. You take what you squared in the first one, x minus 4, and you add what you squared in the second one, which would be a y. Then you take what you squared in the first one, x minus 4, and you subtract what you squared in the second one. And that is how you would factor if you recognize the difference of two squares pattern in that one. Okay. Now, another difference of two squares here. It's the same thing. I've got something right there that I am squaring or squared, and I've got something right here that I've squared. So if I go and try to factor this, then what I can do and that reminds me, whoops, let me back up. I forgot to do something on that last one. Sorry about that. Just walked right through it. I didn't forget to do something, but I forgot to point something out. If you can go ahead and simplify something in here, you would do that. However, here I cannot. So you'll notice I have an x minus 4 plus y. If any of those have been like terms, I would go ahead and simplify that. But since they are not, I leave it exactly how it looks. Okay. Now in this one, I'm going to be able to end up simplifying a little bit. But what we have first is a difference of two squares. What did I square here? I squared a 2x, right? And just as a habit, I kind of like to fill out both my first terms first, especially when I know kind of where I'm going with it. It's a difference of two squares, so I'm going to add in one of them, and I'm going to subtract in the other. Oh, what did I square here? It's pretty simple, an x minus 3. What did I square here? An x minus 3. Right there. Okay, so what I can do now is I I can go ahead and combine some like terms. 2x and x would be 3x minus 3. And 2x minus x would simply be an x. And minus a negative 3. Here's where a lot of people mess up. They'll just put that x minus 3 there when it should, in fact, be x plus 3, because I subtracted an x, but then I subtracted a negative 3 to make it positive 3. I'm not quite done. As you can see right here, I've got a common factor that I could take out. 3 times x minus 1 times x plus 3. Okay, we're good to go. Alright, perfect square trinomial, and then the difference of two squares. Okay, so let's first look here. What do I want to do? I want to look to group something. So here's what I would look at. I kind of see these two contain an x, and then I have a 1 here. So I'm going to look at that, and I'm going to think, hey, I might be able to factor just that trinomial right there. It appears that I, in fact, can do that. And if I look close enough, that is equal to x minus 1 times x minus 1, right? And then I would have minus y squared. Okay. Well, what that does is that gives me x minus 1 squared minus y squared. Well, you might think you're done, but now I notice the difference of two squares. I've got a square here, and I've got a square here. So what I'll do, I will take x minus 1, x minus 1. I will add y here, and I will subtract y here, because that's what you have in the difference of two squares. Can I simplify anywhere? No, it does not appear I can. So I'm good to go. Alright, now perfect square trinomial, then the difference of two squares. Let's do that again. Right away, I look and see, okay, I think if I'm looking at a perfect square trinomial, I think I can kind of separate these last three terms, right? Because I've got a y squared there and a y and then minus 9. So let's do this. 9x squared. Now what I'm going to do is I'm going to kind of factor out this negative here. Okay? Which means it's going to change the sign of all of them. That's now going to be a positive y squared. I'm going to subtract 6y. I'm going to add 9. That's key, obviously. It's important that you change all those signs. So now, what I'm going to do is, this is a perfect square trinomial. So now I've got a 9x squared minus, and this would be the same thing as y minus 3 times y minus 3, or y minus 3 squared. And once I do that, now I notice that I've got the difference of two squares. What did I square here? A 3x. What did I square here? A y minus 3. And when we have a difference of two squares, we've got one positive and one negative. I can't simplify anywhere in there, so I would just leave it like that. Okay. Now, last problem I'm going to show you, there are two different methods to do this. The first method is to look at, I'm taking something squared here, and then I've got this same something. So that's the same as having like an x squared and an x right there, which is commonly what we will factor. We'll have an quadratic term or a squared term, and then a linear term or an x term. So you kind of need to think about this as just being an x squared and this as just being an x, and then you can factor it using a trial and error method. So my first term is going to have to be x minus 4, right? X minus 4. And then I have to find two numbers that when I multiply them I get a negative 24, and when I add them I get positive 5. Hopefully you were all taught factoring that way. So what can I multiply together to get negative 24, yet add and get 5? Right away, you should start going through the factors of 24. Obviously, it's not going to be a 1 and a 24. It's not going to be a 2 and a 12. Next option is a 3 and an 8. 3 and an 8 is 5 away from one another. So when I add, if I have to get a positive 5, that means the 8 should be positive. The 3 should be my negative. Okay, right there. Now I will simplify. I've got x minus 4 plus 8, which is x plus 4. And I've got x minus 4 minus 7, which would be x minus 7. Okay, so you could kind of see it that way as just a simple factoring problem. The other way to do this would be to go ahead and multiply all that out. And after you multiply it out, then simplify and factor. We should end up with the same value here, the same answer. So let's go ahead and do that. If I had x minus 4 squared, x minus 4 times x minus 4, right? So I need to be thinking about it that way. X minus 4 times x minus 4. What I don't want you doing is writing down x squared minus 16. That is completely incorrect. Okay? So I'm going to FOIL this, or just distribute the x and distribute to negative 4. Anyway, I should end up with x squared, because x times x is x squared, minus 4x minus 4x, which would give me minus 8x. And then negative 4 times negative 4 would be plus 16. Now I'll move on and distribute this 5 plus 5x minus 20. And then minus 24. Now I will combine all my like terms. I don't have anything that goes with x squared. I've got a negative 8x and a positive 5x, which would give me negative 3x. I have a 16 minus 20, which would give me negative 20, or negative 4, I'm sorry. And then minus another 24 would give me negative 28. Now that's pretty simple trinomial I look at. Obviously I'm going to have an x and an x. I need to look for something that when I multiply it together, it will give me 28, a negative 28, and when I add it, it'll give me a negative 3. So 1 and 28, no. 2 and 14, no. 3 doesn't go in. 4 and 7, the difference between 4 and 7 is 3, so I'm thinking that's it. My bigger number is going to have to be negative, because when I add them I have to end up with a negative. So if I'm adding here, I'd put 4. I'm subtracting there, I put 7. Alright. Now that's just a pretty quick review on all of our factoring strategies. If you have any additional questions, be ready to answer those. We'll have some fairly simple a daily problem when you come in, and we'll go from there.